Hello, and welcome to this presentation of the Building for 2050 research project carried out for government. This presentation is called Accelerating the Delivery of Low-Cost, Low-Carbon Homes, because that's really the whole purpose of the research that was carried out by a multidisciplinary expert team. Next slide, please. The project at the time was commissioned for BEIS, which is now the Department for Energy Security and Net Zero, and it was delivered by an expert team comprising AECOM as multidisciplinary consultants and project lead, project managers and technical lead and social researchers. Pollard Thomas Edwards leading the architecture, design reviews, site reviews, audits, discussions with site personnel, and Four Walls as experts in building performance, and LCP Delta, who are experts in energy services. You will hear today from AECOM, Pollard Thomas Edwards and Four Walls, and then AECOM again at the end around the resident experience. Our client for this project was Roger Littlewood as the project manager, and Roger will explain the introduction to the project. Then I'll tell you about how we delivered it, and then provide a summary of the drivers and barriers for low carbon homes. Then we'll move on to Tom, who'll tell us more about individual case studies that were studied in depth and what this means in terms of low carbon homes going forward. The post-construction testing and monitoring will be summarised by Ian Mordett, and Alex Lurchek will be providing information on the social research as it relates to residents.
Hi everyone, I'm Roger Littlewood and I was project manager for Building 2050 from the energy research team in the Department for Energy Security and Net Zero, which until recently was known as BEIS. Next slide, please. Okay, so a very brief introduction to the project from me and why we commissioned it and wanted to deliver the project in the first place. The project has been a piece of end-to-end research and holistically looking at the entire process from the conception of building designs to being lived in and what they're like to live in for a good while after they're occupied, and included design reviews, site reviews, testing and monitoring of the homes once they're occupied, great deal of analysis, and also social research. I think is one of the other unique things about the project is that it combines the social research with the physical observations. Involved a wide range of stakeholders, including construction industry, residents in the case study homes, and a wider group of consumers, among others. Now, from our point of view, as a government department who commissioned the research, why do this? Well, we want to understand costs and performance once occupied of low-cost, low-carbon homes, to understand the barriers to and the opportunities of scaling up this type of housing and how we might go about accelerating it. To look at once occupied, how these homes perform in practice, what are they like to actually live in. And like any good piece of research, it was designed to provide evidence for future policy, and as well as current and future standards, whether that's regulatory or voluntary industry standards. And this is all with the aim ultimately of helping new build homes reach zero carbon by 2050 and reduce the requirement for future retrofit. Although to note that the project was actually conceived prior to the net zero by 2050 targets, which was put in place in 2019. We actually began, and this is the delivery of the project, obviously it was conceived a while before that, began the project in summer of 2017. The research, the data gathering phase of the project completed in 2021, and then throughout last year, analysis and write-up followed before the report was published in December 2022. The project was funded and managed by the BEIS Energy Research Team, which is where I sit, and delivered by a consortium led by AECOM, including Alison and co, who will talk you through the subsequent sections of this presentation. Thank you.
So our approach to this project was to study in depth 4 case studies across different tenures, and to really look at it right from the very beginning, the decisions why people chose to do low cost, low carbon homes, all the way through to the resident experience of people living in them for a period of time, monitoring that performance and what did they experience. So having started with a literature and market review, we did these for in-depth case studies and all the way through, and then professional interviews to supplement the case studies to get a wider view from the industry, including some workshops with industry. We carried out research with householders and residents within the homes, but then we topped that up with a survey of 2,500 consumers to get a wider perspective. And we also had expert input from government and from an external steering group. Next slide, please. So the experience captured, a wide range of experience has been captured through this project. The developers had different drivers and funding models, and the design teams also chose a range of different routes to deliver low carbon homes. So this project, we believe, is unique in that it focused on social research with the developers and the design teams, and in-depth studies during construction as well as the post-construction testing, and then the social research again with residents through interviews, monthly diaries, focus groups, etc. We also carried out a comparison with SAP to see what difference the results which were measured on site through post-completion testing gave when they were applied to modelling compared to a predicted energy performance. And overall, we looked at how low carbon homes fit within a changing energy system, and possibly one of the most interesting things is the aspect of the review of additional capital costs, how much that is a barrier or not for developers developing these types of homes. Next slide, please. So to cut straight to the findings, we'll hear more about the process as we go forward. Really, the main drivers were the policy and regulations. So number one driver was policy and regulations. Building regulations, but also planning policy were very important within these projects, and reasons why people chose to go beyond required energy performance. There is increasingly a business case to do it, with more and more funding driven by ESG funding and investment groups, and that was a change during the course of the research. Some of the projects had low carbon stakeholders driving the innovation. That could be an expert group, such as an academic body or an individual company that were experts, or indeed a wider perspective, for example, in Swansea City Deal vision, to see how the use of local timber and local timber could boost the local economy as well as driving forward low carbon homes. Some of the schemes had grant funding, and that provided an incentive as well. If it's a grant funding for innovation, then those developing homes that were going to qualify for that were looking to really maximise the use of innovation and different technologies. And overall, during the course of our study, we found this overall increased awareness of the climate emergency, which might range from councillors through to residents. And so that drives the desire to deliver against that through low carbon homes. Just as the main driver is policy and regulation, we also found that the main barrier is policy and regulation, because regulations are not driving holistic low carbon designs. They're not currently focused on embodied carbon, building energy performance, or post-occupancy engagement and simplicity for users. Increased cost and scheme viability was less of a barrier than originally thought. And we found that some of the developments only had an increased cost of 1% to 3% more, whereas initial discussions with stakeholders, they perceived that likely to be 5 or 10% increase in cost. And very much the cost increase relates to the simplicity of design. So those that had a higher cost had focused more on innovation, had achieved grant funding towards some of those additional costs. There is a concern, and it acts as a barrier, the concern about the lack of electricity. So each of these homes had an electrical form of heating and no gas. And so that means that they're dependent on the national grid to provide that electricity. And there's a whole model here whereby the upgrade, if necessary, for local infrastructure such as electrical substations is borne by developers and not in the traditional way of paying back simply through the standing charges, as would be the case for gas infrastructure being provided. Another barrier that was put forward is some developers have concerns that if they price in additional cost of low carbon measures, then they will be saying that the price that they will offer for a site would be a bit lower than for somebody providing to a regulatory benchmark or minimum performance. And therefore, they have concerns that if they can't pass on the cost through increased sales prices, then they won't be competitive and they won't actually be able to deliver homes in the first place. And then the final barrier here was that the market is dominated by major house builders. At the time, there were no major house builders building low carbon homes. So if that's not being taken forward by the major house builders, then those who are SMEs trying to get into the market will struggle. Next slide, please. There were some more barriers relating to technology. So as people build low carbon homes, they're not building the same thing. They're not just building with a gas boiler and probably a gas combi boiler, program radiators. So they're moving to different forms of heating, typically air source heat pumps and electric forms of water heating. And there needs to be a better understanding of what that might mean in terms of the space required within a dwelling, the location, the need for using mechanical ventilation with heat recovery because of high air tightness rates to get good building performance. So it's this barrier of not necessarily working together closely enough, building services and architects, and especially as there's been a whole culture of not needing to work together very much over the last few years because the design is being very simple and very replicable in terms of the building services and hasn't needed expert input. There is a reluctance within the construction industry to change, so there is an innate inertia. They have their supply chain set up. They get deals from larger house builders. And as I say, they haven't needed to bring in expertise regarding the design of building services or how that might integrate with structure. So with the architecture. So that means a whole new mindset. And we found and was reported insufficient knowledge and skills. And although people typically say that perhaps they think that's at the site, this goes right the way from the original, those preparing briefs in the first place, deciding what to put, whether to build low carbon homes, all the way through to sales teams and those handing over properties who need to understand what this new low carbon house is and how the homeowner will interact with it. Another barrier that was reported by developers in the construction sector relates to whether the potential occupants are really ready for the change away from what they're very familiar with in terms of a gas boiler, and if it's a combi boiler, hot water readily available. There is a concern about perceived risk of overheating, whether more airtight homes will provide poorer air quality, whether the residents themselves will be anxious about maintaining different technologies and whether they can get somebody in to maintain them as they need, and whether they will be too complicated to operate, and even whether the ventilation system will be noisy. So because the residents are not familiar with such homes, then if they're not comfortable, they might not want to buy them. So this is potentially a barrier. Next slide, please. So that was what we were being advised at the beginning of the project, were the barriers for developers and the construction sector more widely. After the full range of 5 years of research, focusing in detail on the case studies, but also the wider inputs that we had from industry and from residents and householders in general, we ended up with lots of learning points. Firstly, focusing around supply and demand, and then secondly on performance. So industry groups feel they need certainty on the future for low carbon homes, what the scope will be, what the timing will be of regulatory requirements, where planners can set the bar if they wish to go beyond regulation, so that they can plan ahead. So we are talking here about a step change in the performance of homes. We're now, this project was around low carbon homes. We're now very much hearing zero carbon homes. And if the industry has to gear up for this step change in what they're providing and in the performance of these homes, then they want certainty that when these changes have to make, and they need notice and they need to plan for it. So if a developer is master planning a site at the moment, these homes might not come forward for the next 10 years. And so without this longer term view, it's extremely difficult to make plans and provisions for low carbon homes. Local planning is also a key driver. And we're seeing that increasingly, that some areas of the country are deciding to set their own policy. Now, that can be a benefit because it does then mean that there is a level playing field for everybody who is coming forward with their designs in an area, because they all have to achieve a certain standard. There is a role that the public sector can play in promoting more low carbon homes by setting their own performance requirements. Probably the biggest perceived barrier would be that these homes are going to cost more, and if they're not required by planning and they're not required by legislation, why would anybody want to do it? Well, if they're well planned, well constructed, the capital cost uplift can be minimal, but it needs thinking about from the beginning. There's no point in changing the specification partway through, because you won't end up with an optimised building fabric and services specification. So it's all around thinking and making sure it's well planned and then well constructed, so that the equipment installed can deliver the heat loads and the heat losses that are encountered. Generally, you'll hear it a little bit later about the consumer perceptions, but generally these homes were no more costly to buy than standard homes. So there was a capital cost uplift, but actually that was not passed on to the consumers. What it was a barrier is that there just aren't that many low carbon homes. And if you want to buy one, how do you find out what it is? So at the moment, the only information would be through the energy performance certificate and whatever marketing material the developer might choose to put forward. But there's just not really a ready means or a ready supply of low carbon homes for those that might want them in the areas in which they want to live. So if developers do market them, then that's likely to increase the demand, especially if they are fairly open around the likely running costs, the features, whether they might introduce any complexity or constraints on occupants, and if they provide sufficient post-occupancy support, because people will be unfamiliar with some of the technologies and will need some help to optimise the performance and minimise the running costs. And another learning point really is that the construction sector and the energy services sector need to engage better. So there have been huge advances in the energy services sector in recent times. You can move to something like heat as a service. You can have third-party management of your home across a number of homes if it's part of a new development. And the construction sector doesn't seem to really have understood that energy use is a key part of home design as we go forward, and they need to better understand what the energy services sector can offer, from the forms of heating within the home through to means of avoiding significant energy infrastructure costs through balancing demand and it not all happening at the same time. Next slide, please. So then we move on to energy and carbon performance, because having built these homes, it's absolutely vital that they perform as intended. And in our experience, the best way that they can perform well is to adopt a simpler design that makes it easier to build, easier to commission correctly, and easier for the residents to operate. But there needs to be better knowledge of what's out there. So there will still need to be product development, and house builders will need to improve their knowledge of what these technologies and services are to help improve the overall energy and carbon performance. We called these low carbon homes, but actually we realised that if you only focus on carbon, you can have some unfortunate outcomes. So therefore, it's really important right from the beginning to be focused on the end point, which is that people are comfortable in their homes, that they understand how to use the systems that they've been given within them, that they can manage their homes well, and they can have low running costs. And that means that you need a range of output metrics set right from the beginning, not simply low carbon. So you need to be thinking about energy consumption and usability and comfort and simplicity of control. And only through considering the design in the round are you going to get the best energy and carbon performance. And it's really essential that this performance is delivered, because both running costs and the carbon emissions will then be low. And the running costs are such a key driver for people who are looking to get a low carbon home, that and their environmental impact. So you've done the design, you've built it on site accurately, you've commissioned it, etc. But really, it's not a fit and forget solution. You need to include enough time for resourcing the handover and making sure that people are not being presented solely with manuals, but actually guidance and support. And when they understand and operate their homes efficiently, the energy and carbon performance will be much better. A point here around energy use and the energy system. So where I'm saying we want to minimise energy use, but it could be that optimised carbon emissions and bills result in slightly higher energy use, because the carbon emissions associated with energy consumption per kilowatt hour are not the same 24/7. So with different forms of energy, with renewable energy available in different amounts at different times of day, then we now have a dynamic energy system. It's not simply 1 kilowatt hour of electricity has the same CO2 impact kilograms whenever it's used. So understanding this dynamic relationship between energy use and the energy system will help us need less, focus on storage, focus on time of use tariffs, and make sure that overall we've got an optimised system and running costs are managed well. So finally, to improve energy and carbon performance, we need to upskill and improve collaboration across the industry. There's definitely a need for expertise in low carbon design to ensure that right from the start, the brief is set correctly. It has a number of metrics in it, not simply carbon, that it considers the end user all the way through, that the orientation is correct, that all the lower cost elements of low carbon homes are maximised, so that the building fabric, the building form are very good, and then all the way through to commissioning homes correctly, getting systems right, making sure they're accessible, ensuring that there are people in the industry trained up to be able to maintain heat pumps and newer technologies, all the way through to the handover, which is often done by the sales team. So even the sales team need to know what they're offering, and before that the marketing team, so that people understand what their new homes are and can get the best from them. Next slide, please. So really successful new homes are integrated. So we have the developer who's working with the design team, with planning and planning policy and building regulations, has an understanding of energy infrastructure, is backed by a funder who perhaps is really interested in long-term investment and ESG, environmental, social and governance drivers. The developer has good understanding of the products, as does their design team available, and their contractor is engaged and fully understands why they need to deliver a high level of quality on a site. And that should lead to very happy residents who have low bills, are warm in winter, they don't experience overheating, they have properties that are easy to maintain, they have sufficient hot water, they have easy to understand and use control systems, no restrictions on how they live in a home, and that's been really facilitated by a good handover and good availability of low carbon homes in the first place. Thank you. Next slide, please.
Thanks, Alison. Hello, everybody. I'm Tom Dollard, partner of sustainability at Pollard Thomas Edwards, and we were leading on the design reviews, site reviews, and stakeholder interviews of the low carbon case studies. And the case studies were really there to address the question of practical implications, or the design review and the site reviews were really there to show us what were the practical implications for industry, what were the practical implications across the case studies in terms of program, cost, the design, the layouts, even the look of the homes, and the buildability, whether these homes were more difficult to build, whether they presented any unique problems for the contractors and for the supply chain, and any more specific site implications that we found. So we carried out a detailed review from the beginning of a project. We were there with the brief, the pre-planning, detailed design, all the way through to site and handover. And we had typically 7 site reviews, 7 site visits to assess and witness all stages of construction. So next slide, please. So the 4 case studies, this was the first one, Marmalade Lane in Cambridge. And this was a co-housing community, 42 homes. There were some apartments as well as some terraced houses. And they adopted a fabric first approach with a off-site timber panel. And that's relatively unique. They had the windows installed in the factory, so they had a very good airtight seal with the windows and the panel. And then it was no gas. That was requested by residents in the brief. And so therefore they had air source heat pumps to supply heating and hot water. And because of the low air tightness and the fabric first, they had a mechanical ventilation heat recovery system. Next slide, please. This is a schematic of the design, some of the key services that produce the low carbon performance. Next slide. The second case study was in South Wales, in Neath, and this was a social housing landlord, Pobble Group, so affordable rent, 16 social rent homes. This was also built with MMC, with timber SIPs in a local factory, and it had building integrated solar PV, so you can see that in this photo. It was PV film onto a steel roof. And then the PV fed individual batteries on each house, and then there was the hot water provided by an air source heat pump with a preheat provided by transpiring solar collectors. Again, it had some on-peak electric space heating as well, and MVHR ventilation. Next slide. And here's a schematic of how that's been designed. You can see the unusual, slightly unusual technology, the transpired solar collectors on the south facade, and then the PV on the south-facing roofs, and then the heat pump in the house, and the ventilation in the roof void. Next slide. The third case study was Etopia Homes in Corby, 47 homes this time, slightly larger. Again, it was with MMC construction, this time using steel SIPs, so a steel panel, and a small format panel as well that was put together by hand on site. And they were aiming to be energy positive. The previous case, there was aiming to be active homes. This was quite similar in terms it was meant to be energy positive over the year. And it did that with a lot of PVs on the roof, some PVT on the roof, PV thermal array, and a ground source heat pump with an earth store energy bank. So again, quite a complex MEP system. And then it had a smart home energy management system. The next slide, please, shows the schematic of how that works with the earth store energy bank and the ground source connecting into the cylinder. And then you've got the PV and the PVT charging the battery. Next slide, please. And the final case study was in London, an apartment scheme this time with two townhouses to the side of this apartment block. And this was innovative and low carbon because of its air source heat pump. And it was a communal air source heat pump linking to providing an ambient loop that linked to water source heat pumps in each flat. Relatively innovative solution, and it's also supplemented by solar photovoltaic panels. And to note that this was a traditional brick construction with a concrete frame, so not fairly normal construction for London there. Next slide, please. And this schematic shows how that ambient loop is fed by an air source heat pump on the roof and then connects to the individual heat pumps in each flat. Next slide, please. So the findings, low carbon design. From the design review, you can see this image is showing our typical checklist from a site, how we would compare the design specification with the site observations. And all the time we're comparing to see if there are any differences, why there would be differences, and then speaking to the trades and the site managers and the team on site to find out what was the cause for these differences, or even sometimes they're exactly spot on. So why had that been the case? The main finding was that there are a variety of different ways that you can deliver successful low carbon homes. Generally, they required an electric heating hot water. So in this case, they're all a type of heat pump. And we also find that complex designs have been simplified further on. So some of the developers, all of the developers are still in business, and they've simplified these designs on their next sites. So next slide, please. In terms of the cost, we analysed that at various different stages: the construction estimate prior to construction and the final account after construction, and we can clearly see there is an additional cost to low carbon homes, and some of these case studies that were able to refine the design and go through a value engineering process showed that to be 1 to 2.5% extra. But then some of them where they possibly had where they had grant funding and a more complex design were up between 10 and 20% extra. So the cost uplift depends on the source of funding, and it's obviously linked to the design and the complexity of the installation. Next slide, please. And then the skills gap, Alison mentioned that in the findings. We saw that on site and in the design review process where we were part of meetings as well. We saw that there is a shortage of skills across the industry at each stage, and that's going to be a challenge for scaling up. We also saw that developers were unfamiliar with specialists providing low carbon services. So that link between the energy system and the housing industry as well being a gap. And next slide, please. And then just a note on it, MMC, we had 3 out of 4 of the case studies delivered using a panelized system, and we certainly saw the benefits in that. We saw that the panels themselves were performing very well, and I think Ian will show you a bit more detail on that. But they do depend. It depends very much on the design still, and the junctions between site and the interface between site and the factory is critical. I think that's it. Yes, over to Ian. Thank you.
Thanks, Tom. So yes, I'm Ian Mordett. I'm a building performance researcher at Four Walls Consultants, and I'll give you a summary of the findings from the post-construction testing and the in-use monitoring that we carried out at the developments. Next slide, please. I start with the findings from the post-construction testing. We conducted a number of tests. This typically included coheating tests, in situ U-value measurements, thermography studies, and air tightness testing and ventilation measurements. Many of the tests are to evaluate the fabric efficiency of the case study dwellings. And typically for the post-construction testing, we studied 2 sample dwellings on each case study development. What we tended to find across these developments were that certainly for the measured U values, these are often found to be quite comparable to the design values. The biggest issue we tended to find on the fabric side was the air tightness and thermal bridging. There were still some challenges there. But overall, the fabric was generally better than equivalent new homes that are built to meet the minimum standard for energy efficiency and carbon emissions under Part L. But using these findings from the post-construction testing, we recalculated the SAP calculations and compared those SAP calculations with these adjustments to those provided by the developer as part of their Part L compliance submissions. And for the fabric efficiency part, the DFEE value in SAP, we found that the adjustments with the post-construction testing saw a 10% increase in the fabric efficiency, so that's poorer than the developer's SAP. And in one case, one of the schemes was twice as bad as the predicted, so 100% poorer than predicted. But in that case, that wasn't necessarily to do with defects that were found through the air tightness and thermal bridging alone. That was simply the readjusted SAP took into account the heat losses through the communal walls into an unheated corridor area and communal areas that hadn't previously been accounted for in the developer's SAP. Next slide, please. So, as mentioned, one of the areas where there were challenges was the air tightness. And a lot of the schemes had set themselves fairly challenging air tightness targets. In all cases, the design air tightness was below an air permeability of 3 meters cubed per hour per meter squared of envelope area at 50 pascals. And we did find some comparable test results, but in many cases, our retested values were higher than the developers' tested results. And some of the reasons for that were to do with, as the top left image shows, we've got dark blue, which is colder air coming in through service penetrations through a loft. So we've got an MVHR outlet there, which is sealed for the air tightness testing, but there's still leakage around the ceiling connection. And you can also see there's a light fitting there where there's air leakage occurring through that. On the top right, there's the junctions between the external wall and the floor, the external wall here being off-site manufacture. So there's likely to be some perimeter expansion strips that haven't correctly expanded or connected to the floor system. And so there's an amount of leakage occurring on those junctions. The bottom left image there shows an external door, and there's typically quite a lot of leakage occurring across the developments at door thresholds. Door thresholds are often quite a weak point, not just for air leakage, but also thermal bridging. And the bottom right image, that shows you don't always need a thermal image to identify leakage points. On a deep pressure test, this shows that dust that is been sucked out by the pressurization system or depressurization system. And this is air leakage occurring between a party wall or a communal wall into an apartment. So air leakage does occur, it is quite significant between these zones as well, because not just external walls. Next slide, please. The other area where there were challenges was associated with thermal bridges. And in this case, the top left image here, where we want the yellow and red areas are showing heat loss coming out of the building. And the column that is shown in the image there, you can see the temperature gradient, hot at the top with the red color at the top, and the heat being transferred down the column. So it's balconies and steel penetrations through the thermal envelope of the building were found to be weak points. And also thermal bridges at door thresholds, external door thresholds, where the structural components of the external door have tended to disrupt the perimeter insulation. So that was another key thermal bridge finding on many of the developments. Next slide, please. Moving into the monitoring and combining our monitoring findings with the post-construction testing, we aim to get 10 homes monitored on each development. That's in-use monitoring while people are living in them. And the intention was to measure the heating and hot water and other energy uses. So this slide is showing the hot water, the space heating, energy use across the developments, and they're being split out between houses and flats. So in each case, what we've done here to allow comparison across the developments is the energy use has been changed to a ratio to compare with the Part L SAP 2012 notional building. That's shown by the red dotted line. So we want all of the stacks to be below that red dotted line for them to comply with Part L. The orange stack is the measured energy use in each case, the red stack being the developer's original SAP, and the blue colour is the Building for 2050 readjusted SAP to take into account the observations that I've just discussed about air leakage and thermal bridging and other issues that we found. And what we found is development 1, both the houses and flats used around 3 times the predicted energy compared to the developer's design. And development 2, the houses did use quite a lot more than predicted, about 3 times more than predicted, and the flats were around double the prediction. In development 3, the flats used around 4 times as much energy as predicted, but in all cases, when we compare the readjusted SAP, so that's the blue stacks, you can see there's the gap has closed, and there's different reasons for the gaps closing, and in development 2, the houses there, you can see the gap didn't close as much as expected, but there were ongoing issues with that development during the monitoring process. Next slide, please. The post-construction testing that we carried out, that didn't really impact the predictions for the hot water. And in this case, you can see the blue stacks and the red stacks. So that's the Building for 2050 adjusted SAP in blue and the developer's original predicted SAP. There's not much change to these predictions. Compared to to the measured energy use, in all cases, the measured energy use was less than both predictions. And some of the reasons for that were to do with, in many cases, certainly for larger homes, there was less occupant density. So we might have a 3 or 4 bedroom house that's only got 2 or 3 people in it. So there's going to be less hot water demand than the SAP calculation would have predicted anyway. But in other cases where there is greater dwelling density with a larger number of occupants, there was feedback from some of those occupants that they didn't have sufficient hot water for their needs. And even so, that particularly was the case in development 2, but even so in that situation where they probably would have used more hot water energy to overcome that, it still didn't increase above the prediction. Next slide, please. Looking at CO2 emissions now, so this is the same as the energy charts in that we're representing the comparisons using a ratio to the Part L 2012, Part L 2013, which uses SAP 2012. So that's shown by the red dotted line. And again, we want all of our stacks to be below that line. If we look at the green stacks and the purple stacks first, so the green stacks are the those results by the developers as built SAP calculations, and the purple being the Building for 2050 adjusted SAPs. We can see there's quite an increase across the developments between those stacks, and certainly for development 2, where the intention was for them to be more carbon positive, that didn't really materialize in practice because a lot of the thermal defects that we observed prevented that from happening. In development 1, you can see the flats there. Even though the energy use wasn't found to be an issue, the flats, we did find during the monitoring period that there was an issue with the COP of the communal air source heat pump system. And that was being rectified during the monitoring period. So the COP wasn't as optimal as it should have been. And whilst we have recorded that, it's probably a slightly unfair comparison for the other developments because we just took the manufacturer's COP as part of the SAP calculation. We didn't adjust the COP in those. We only adjusted the COP to reflect the information that we knew for development 1 flats. So that's probably why that green stack is so much higher. The blue stacks that you see, that now represents the new carbon emissions associated with the current SAP, which is SAP 10.2, and that shows that there's a significant reduction against most of the developments when you account for the new emission factors, and those new emission factors reflect the progressive decarbonation of the national grid. Next slide, please. So to finish on comfort and indoor air quality, because this is obviously important for residents as much as the energy bills they have to pay. They have to be, you would expect, to be comfortable in low carbon homes. And the feedback generally was quite positive. Most residents felt good levels of thermal comfort during the winter time, certainly. Their homes were comfortable throughout, and they said there was good heat retention. And there were no issues really with condensation and mold, as you would expect in these sort of homes. The fabric is nice and warm, and so there's little issues to do with condensation and mold. Where there was some condensation or mold, we found that was due to suboptimal commissioning of the ventilation system rather than particular fabric defects. In 2 of the schemes, some residents did report that the air was dry, but on those schemes, rather than under ventilation, which is a common finding, it was more due to to over-ventilation. So the ventilation had been commissioned to move more air in than was necessary, and in winter that can create drier conditions. So that's backed up by our monitoring those residents' observations. And also we found quite commonly that these properties are quite high tech. There's lots of equipment in there, and the information given to residents about how to use their systems, and particularly in the case of mechanical ventilation, was not sufficient enough for them to use their systems optimally. And finally, these homes being well insulated, we did observe and monitor an amount of overheating in some of the homes. This was reported by residents, and we did observe it in the monitoring. So this is an area of increasing importance that designers will need to factor. Thank you. I think that's me.
Thanks very much, Ian. So, hi everyone, my name's Alex Lurchak. I work in the social market research team at ACOM, and together with my colleague Joe Christensen, we were responsible for conducting the social research with residents at each of the 4 case study developments. Next slide, please. So the social research element was recognised as being very important from the very start. It's not just important to understand about construction quality and the performance of the homes and technologies. If the aim is to accelerate the uptake of low carbon homes, it's very important to understand the demand and views of people towards such properties. And for those living in them, understanding what their experiences is and are a significant part of that journey. The questions you see on screen are just some of the examples of what we looked at with our research. Next slide, please. So to give you a little bit of background into our methodology, at each of the 4 schemes, we collaborated with the developer and their teams to identify potential residents who would be willing to participate in the social research. This resulted in a sample of 55 residents across the 4 schemes who had made the decision to either purchase or rent a low carbon home. With each resident, we interviewed them prior to occupancy to explore their decision-making process and to understand their general expectations about their new homes. To discuss their views and experiences in their homes after moving in, we interviewed each resident after 3 months of occupancy, and then we conducted a focus group with residents at each of the development after 12 months of occupancy, or as late as we could if it wasn't the full 12 months. In addition to the interviews and focus groups, each resident produced short monthly diaries over the course of occupancy to reflect on their views and experiences, and this allowed us to see how their experiences and attitudes changed over time. And these diaries were also really useful comparing against the monitoring data collected, as Ian was just talking about. It helps us to see where any change in behaviour had happened or any key changes that might affect the data, like going away on holiday for a few weeks and things like that. The social research focused mainly on the 4 case study developments, but a wider survey was also undertaken with a larger sample of consumers just to understand the interest and demand for low carbon housing on a larger level. Next slide, please. So I just want to share some of the main overarching findings from our research in terms of the perceived drivers, barriers to living in a low carbon home, as well as the benefits and challenges faced while living in them. So starting with the drivers, we found that the main factors influencing home buyers and renters were location, price, and the size and design of a property. Although less influential for most, the specific drivers related to low carbon homes were lower energy bills and running costs. Now, this was the main driver for almost 60% of the wider survey respondents, and most residents from the social research we did said it was a key attraction for them, and it was also a key selling point that some of the developers used. Having a reduced environmental impact was a driver for some who were specifically seeking a low carbon home, and 50% of the wider survey respondents said they were expecting it to be one of the main benefits. Having a warm and comfortable home with good air quality was another key driver for most, and they were expecting their homes would maintain a steady temperature throughout the year. Another driver for many was having a new, modern and high quality property. And the final driver was having a gas-free home, with some people saying that they felt it made the homes greener, but also safer to live in. Next slide, please. So in terms of the barriers to purchasing or renting a low carbon home, although the case study properties were sold at market rate, as discussed earlier by Alison, Around half of residents believe that low carbon homes in general are more expensive than traditional homes. We also found that this was the main barrier perceived from those who answered the wider survey, with over 60% of people saying that this was one of the main barriers. A key physical barrier was considered to be the lack of availability and awareness of low carbon homes across England and Wales. As mentioned earlier, how do people find out about specific features of a home that makes it low carbon or more sustainable? How do you find about where these properties are, where they exist, things like that? In terms of living in a low carbon home, one of the main concerns was that the technology would not perform as expected. Some shared concerns about the reliability of systems and what maintenance might be required from them. Another concern with some residents was that technologies, wiring, pipe work, and things like that might be very visible and take up usable space in the home. They just weren't sure how much it would differ from what you see in a traditional home. And finally, there was some concern shared in the pre-occupancy interviews that because the properties were different to traditional housing, there could be more snagging issues, or the completion date for the homes might slip, leading to potential delays for when people actually move in. Next slide, please. So from living in the case study developments, residents considered the main benefits of their new homes to be that they were warm and provided a comfortable environment. Most reported that they retained heat well, and although some experienced overheating in their first summer, this generally improved as they got used to the technology, and some also implemented things like solar shading and established window opening routines that worked well for them to manage their comfort in the home. Most residents felt that the air quality and ventilation was good, and very few had experienced any issues with mold, damp, or condensation. For some residents, living in a low carbon home and reducing their environmental impact was considered to be a key benefit, particularly those who were specifically looking to do that by buying this home. However, some said they considered it more of an added bonus, but they did say that they appreciated having a lower carbon footprint without having to significantly change their behaviour. In terms of energy bills, there were mixed opinions and experiences across the developments with these. Some found that their bills were as low or lower than they expected, whereas others found that they were higher than expected. Next slide, please. And that leads us directly onto the challenges. And as I mentioned there, one of the main challenges faced was that energy bills were higher than expected for some people. And in some cases, it was much higher than their previous homes, which they considered to be inefficient, older, drafty. Just they weren't expecting the bills to be higher. This, as Alison mentioned before, shows that having a low carbon design does not necessarily translate to lower energy bills, particularly when moving from gas central heating to an electric heat pump. A challenge that was expected prior to occupancy and was faced by most residents was learning about and using the technologies and systems in their home. While most found it quite difficult, some said they found it easy to understand and manage, but for most people, they said they felt that more training and information should have been provided, particularly in-person, face-to-face training to show people exactly what to do to change their systems and alter their settings. There was also a more general concern around servicing and repairing low-carbon technologies, with this being shared by residents as well as almost 40% of the wider survey respondents. This concern was finding someone to fix things if they go wrong. And residents talked about a few occasions where they called out plumbers or electricians who either didn't know what to do with the systems because they had no experience with them, or they tried to fix them, but unfortunately made things worse. And finally, around half of residents felt that they were constrained with their activities in their new homes because of the systems and the technologies and the way they were set up. And this required them to adjust their behaviour and routines. Examples of this are having insufficient hot water at times, but being used to having combi boilers and had to be more careful about when they use hot water. And some were not able to adjust their maximum space heating temperature. So again, that was an adjustment that they had to make. Next slide, please. And by the end of the research period, most residents said they were still happy with their decision to purchase, and almost all felt that more low carbon homes should be built. However, they felt that a number of aspects should be considered further when designing, building and selling or letting such properties, such as running costs, coordination and complexity of the technology used, having greater on-site experience and improving the handover process and amount of training provided to new residents, just to make that transition easier into homes that they're unfamiliar with. And that's it for me. Hope you found that interesting.